Uh, Good afternoon. Welcome to second live session for the course Functional and Conceptual Design. My name is Neelarnab Dutta. I am a PhD scholar and a PMRF fellow from Department of Design, IIT Guwahati. So in this particular uh, live session, I will be covering key concepts from week 1 and week 2. So week 1 will be more like a recap from the last live session, and I will be mainly talking about the week 2 lecture content. And the deadline for week 1 and week 2 assignments is 9th of August. So both the assignments you need to submit before 9th August. And in this particular session, I'll be helping you with solving the assignments. But since the nature of the assignments are objectives, so I will not solving the objective assignments. Rather, I will try to make a presentation in front of you which will be more objective in nature, so that you will better understand the key concepts that help you in solving the assignments. Okay, so what you have seen in this particular slide is a product. Okay, so most of you might have seen this particular product, which is a saver. Okay, so this particular saver have three rotating blades. Okay, and it's an electronic device which one can use to save the facial hair of a person. Okay, now it has the mechanisms inside, it has the power, it has some sort of functional buttons to operate. So this is typically electronic product. So now the question comes in front of you, that what are the key aspects of a product? So when someone asks you this particular question, like what are the key aspects of a question? So what should be your answer? Okay. Now any product basically have two main aspects. One is the form and the other is the function. The form is basically the enclosure. Okay, the enclosure or the structure. Okay. So form is more like an enclosure or structure that enable achieving the function in more usable way. So the form helps in achieving functionalities in a more usable way. And function defines what technology or science brings to serve the purpose, okay, to solve a particular need or requirement. So in this particular product, for this particular product, function is to save. Okay, now the next questions comes to someone's mind, which is, what are these aspects defined? That means what form defines and what function defines. Okay, now form is not just about a volume, it's not just the structure, it's also defines the concept, how the functional elements are arranged in a particular order, so that a device is usable in a particular way. Okay, so a device can be made more ergonomic by positioning the specific entities in a particular manner. Okay, for example, here you have the control buttons in the reach of a person's thumb, and a person can actually use his hand to wrap around this particular form. Okay, so the positioning of different entities and different functionalities is what is defined in a form factor. So that's why we call form is also something close to a concept. So when we do a conceptual design, we actually explore various forms like form 1, form 2, and we explore how the functionalities or the functional elements can be arranged in a different way to achieve a particular function. Okay. Now function is the saving. Now in terms of functional definitions, we here try to see how a particular function can be achieved. For example, here to achieve the functionality of saving, we have used three blades. Okay, so these are blades. Then probably these blades are connected with some sort of motors, and then there will be some sort of control circuitry, and then we have the power source. So when we define the functionalities, we also need to define the functional decomposition of a particular product. So these are the two aspects of any product: form and function. Okay. Now we need to understand how product evolve over time. Okay. Okay. So products have different generations. Like, so what may be, you need to first think what may be a previous generation product. Okay. Himanshu, so are you a student?
Yes, sir. A student in the
Okay.
course.
So can you tell me what is the previous generation product?
Previous generation product. It may something like the washing machine kind of thing.
Now this is, as I explained, it's a electric saver. Okay.
Yeah. Yeah.
And what do you think is the previous generation product?
For this electric shaver, right?
Yes. So for its electric saver.
We can say the manual razor.
Yeah. Okay. So if you say manual razor, which comprise of a bottom setup with a handle, right, metal piece, then
Yeah.
we have a blade which you sandwich in between a top metal plate, right?
Yeah. Exactly.
So what do you think is the prior generation to this particular product? So if I say this is like the generation, this is Zen. If I say Zen 4, if I say it is Zen 3, what do you think is the under generation before that?
Before that, I guess the blade will be the only one. Maybe the humans uses the blade for the shaving kind of thing.
So you mean the barber blade?
Yeah, something the barber blade and the simple normal blade we can say.
Okay. So let's say this is the blade. Okay. So which
Yeah.
barber use. Okay. Now we can
Yeah.
also again go back in the historical times, but let's we start. This is like from here,
Uh,
and if we see this particular blade, it has a top metal blade portion and something like a plastic or wooden handle.
yeah.
Okay. And who is mainly the user? The user is someone like a barber. So
Yeah.
back in previous third second generation, people generally do not have options to have some product that they can use in their houses to save. So they
Yeah.
generally used to go to barber shops where a barber used to save their facial hair with something like this product.
Yes.
So the user here is a barber, and this product needs some sort of skill dependency because it's not easy for someone who is not skilled in this particular device. He may actually have some sort of cuts and bruises if someone try to use this particular product. So you need some sort of skills. So this is more like a commercial product, someone something which is available in a barber shop. Now the
Yeah.
issues which actually this particular product solve are the shortfalls that this particular product have. Okay, so if this is a razor, so the first one probably you can say this needs some sort of skill dependency.
Yeah.
Then probably you can also say there are chances of cuts and bruise because of this particular no form factor, you can say cuts, bruise. Okay, so these are some of the problems that this particular product tries to solve. Okay, that's why we have a new generation product. Okay, now what do you think this particular product, the generation 4 product, is solving with respect to generation 3?
Uh, I believe it's just providing more functionality basically, because the we can say the generation 3 product is having just a main core functionality to just remove all the hair, right? But the generation 4 is providing you a more feasibility, like you can remove all the hair, have providing more safety when you are using the product, and it's just providing some customization as well, like something you have a blade 1, blade 2, blade 3 kind of thing, so it just adjusts the length of the hair.
Okay, so right. So you have now some of the some of the things which are need. For example, the needs are more like a nice to have. For example, comfort,
Yeah.
and also additional feature, which are additional feature, and some basic needs. For example, because of this particular shape, probably this particular device or the instrument uh, may not, it's difficult to access some particular portion in the face. Okay, so it's difficult to
Yeah.
access some curved surfaces. So since we have something more like a uniform rotating blades, probably this is much easier for someone to access some inner part in the face. And probably the same blade can be also used for hair for other parts of the body. Okay, people can also
Yeah.
use this probably for leg, hair in the legs. So
Yeah.
because of this additional requirement and certain shortfalls of this particular device, we have another generation. Okay,
Yeah.
so that's how actually product evolve. We have a product evolution from generation 2 because of certain shortfalls, right? Those are like clear shortfalls, and there's a change in the user. Initially the users are barber, and the space where this particular product was used is a barber shop. Now generation 3, we have a razor, which the user is now the consumers, which are not like the people, just generic people. And also it is much more safe, needs less skill compared to this particular product. But with change in expectations and with some limitation of this particular product, we have a third, the fourth generation product, for example. So this is how actually products evolve.
Yeah.
Okay, so what do you the guessed from this particular example, like how product evolve over time, like what are the key driving factors?
It's primarily about something culture, we can say. Something like, suppose if we are talking about a user base, right? If we're talking about, so it's also a culture, the need of the product,
Okay,
and
culture.
I guess the technology as well.
Okay, technology. Okay, so mainly I will say like culture and need are from one particular, falls into one particular domain, because need, cultural need is also a need. Okay,
Yeah.
so we can come up with two main drivers of a product evolution. One is the need. Okay, it
Okay.
can be from cultural perspective, it can be actually requirement perspective. Okay, so whatever, one is the need driven
Uh,
product evolution, the another one is the technology driven.
yeah.
Okay, so another example for technology driven can be imagine when smartphones have actually come into picture. It is more like a technology push. So initially we used to have the, so we used to have the simple keyboard phones. Then in back in 2011 2010, that time the technology that come into picture was capacitive and resistive touchscreen, touchscreens. Okay,
Yeah.
because of that, Apple and Samsung launched the smartphones, and it was not a requirement that was actually asked by the consumers, but it was something that was placed in the market because you have something a trendy technology, and then people are used to this particular technologies. That's why we have smartphones. So this particular way of product evolution is technology driven. Need driven, already we know whenever there is a requirement shortfalls from the user perspective, we also can have a product evolution, right?
Yeah, right.
Okay. Okay. So you might have come across these two concepts, these two terminologies, synthetic and analytical method of design, in the first week lecture videos. So do you remember what are these?
I go through in that part as synthetic and analytical, but I not exactly recall this kind of thing right now.
Okay. So
Yeah.
this actually defines in a more formal way what actually we have discussed, the drivers of your product design. So drivers are
Yeah.
need driven and technology driven, right?
Okay.
But these are the terminologies we generally do not speak in a formal design or engineering language. What we use are terminologies like synthetic and analytical method of design. So a synthetic method is something which is like a technology driven approach. So there are not only one particular a way of synthetic product development. So technology driven can be one. Okay,
Okay.
there can be perspective from market driven. Okay, there can be
Okay.
also perspective from resource driven. Okay, that means these are the factors which are actually determining the product evolution. For example, currently there's an ongoing war in Russia, Ukraine. Okay, now because of resource availability, there may be change in tactics or change in new defense products. Okay, because Russia may have limited access because of sanctions. So now Russia may come up with some specific drones which needs some specific resources that are available in Russia today. So this is resource driven. Similarly, market driven can be like if market saw a growth, a trend of particular product, in order to get that kind of business, you come up with a solution. So that is something called market driven. Technology is again technology push. So all these kind of design approaches which drive design are comes under synthetic method of design. Okay. The analytical method is the user centered design approach, which is more like a need driven approach.
Okay.
Okay.
Yeah. Got it.
So have you seen a diagram like this in lecture videos, lecture one? So what do you
Yeah, I
think?
guess I saw it in the past pictures.
So what do you think is the significance of this particular model?
What is the significance of this product I you're talking
This
about? Or
particular
the
model, what this particular like the diagram signify?
it's something about like the process of design, you can say, of the product of design of product, I guess,
So this
or the
is
diagram.
okay. So this is basically a conceptual model
Okay.
of how product development take place.
Oh, okay.
How product development take place, and it generally tries to indicate what are the different factors which influence product design. Okay.
Okay.
So there are two aspects what is defined. One, it said like there is a society, and society have some sort of problem or issues. Okay, now because of that particular problem we have some sort of need and requirements. Okay, and during
Okay.
this particular process we first identify the needs and then we evaluate the needs and the requirements. Okay, and then first we conceptualize a particular product. Okay, so this is the phase where we conceptualize a product, and we conceptualize so that this particular product can be served as a service to the society back, so that it can solve that particular problem. So this is more like a closed loop conceptualization model, the right side, which say that it was defined like a problem is first identified, then specific requirements are formed and evaluated, then we conceptualize something as a service to the society. Okay. Now this particular stage is the conceptual development stage. Now when we have a concept, okay, now to realize
Yeah.
the concept, we have a under set of needs and requirements, which are more like the engineering or the practical requirement, feasibility wise. Okay, so engineering or practical requirement, because we cannot exactly send the concept as a service to the society. We need to actually make it feasible. So the next set of requirements from in the left side, if you see, are the engineering requirements. Okay, now these are needs from the perspective of science and technology. So these in engineering technologies or these engineering requirements, in order to serve a particular concepts, we look into the in the area of science and technology, and from there we collect necessary information, we do the actual designing of a product, and then we reach the again the product stage, and this is how actually product is sent to the society as a service. The left side, this particular space, oh sorry, the right side, this right side, the circle is called conceptual design, and the this particular the left side circle is called functional design. Okay, so this is what this particular
Yeah.
model signifies. Okay, clear?
Yes, sir. Yeah. Okay.
Okay, now I think you might have already understood the difference between engineering design and industrial design. So what we are trying to say here is like the right side, we call that as industrial design. So have you heard
Okay.
about this particular term, industrial design?
Yeah, I heard about it.
So what is
I'm
your
a bit
background?
confused about as well. Yeah,
Amdi?
according to me, like industrial design is something who works on the any product basically. It's from starting to the end. Maybe we can say, suppose if we are talking about, we can simply example of the chair, right? So if you have to design something for this, so industrial design is a designer who initiate the needs of the person, who collect the needs of the person and make the complete form of like solve the problem and make the form of the product as well.
Okay. Okay, so these are two different areas that actually exist in the industry, because when it's a big product, like for example automotive industry or like space industry or some any sort of mobile, even the smartphone industry, we the design practice happens in these two sides. One is called the industrial design, the other aspect is the engineering design. Okay, and we need both these two sides to actually accomplish product design. So industrial design, as I told you, is the conceptual design part, where we address a particular problem. For example, corona was a problem, coronavirus. So need was, for example, when there's a coronavirus, so people fall sick. Okay, fall sick, people die, and if you see the root cause of it, the virus itself, which actually affect the lungs. Okay, so need are, maybe there are different needs that come into picture. Okay, so needs can be like, someone can think of like, okay, probably the virus should not go inside. Okay, so that's a need. So virus should not go inside the lungs. Someone can think of need, for example, if it is goes inside, probably it should not harm the people. Okay, so even if the virus goes inside, the lungs should be safe.
Yeah.
So you can have from this, for the same problem you can have different need statements you can form. Okay. Now specific to each of the statements, I'll say you can actually have set of requirements. For example, this particular requirement is for a mask, which saying like the need is that the virus should not go inside the lungs. The under is like the lungs should not get damaged even if the virus go inside. So probably the need is this one, but the requirement is probably something like a vaccine. Now, as a industrial design practice, you make various concepts. So concept one is probably a mask. Concept two is probably you come up with some vaccine formula, something like that. So here the feasibility of a particular concept is not much. It's not it's not defined in a more feasible way. The idea is to generate concepts and then solve this particular problem in the side of engineering design. So this is where actually we take the conceptual phase, the concept from the conceptual phase to the engineering design phase, and there actually we look for the engineering requirements. For example, if we say mask is the requirement, then probably material selection, how to create the mask, those will be taken care here. And if it's a vaccine, probably people have to now think about how to not discover or invent something like a vaccine, okay, which can actually prevent a person body from getting infected from COVID virus. Then you search in the space of science and technology. Okay, if it is a mask, then it's a basic science and technology. If it is a vaccine, probably you need to go for biotechnology, and then with the knowledge you try to solve the particular problem, and you have the product. Okay, so this is another example, but I'm just giving a rough idea about what is engineering design and what is industrial design.
Yes.
So when we see this particular diagram from right to left, this is the analytical approach of design, which is a need driven approach. Okay, now here, since the problem starts with the virus, this particular problem is actually a analytical method of design. Okay, so that's how we define whether a particular product development activity is an analytical method or a synthetic method. The other approach, which I gave example initially about the smartphone era development, so that can be a imagination of a process when we see this particular diagram from left to right. This is right to left.
Yeah.
Okay.
Yeah.
Okay. Let's see what next. Okay, so that was the content from week one actually. So if you have gone through week one lecture videos, probably with this particular by answering these particular conceptual questions, you may able to solve the assignment questions. Okay.
Okay.
Now we will be discussing the key concepts from week two.
Okay.
Okay, so now you can see here there are different companies. Okay, the trademarks of different companies. What do you think
Yeah.
the common among them? First, tell me about these
Uh,
two companies, Apple and Samsung.
so Samsung is like they are like both of the good name in the mobile manufacturing companies.
Okay, so the common thing among these are the mobile.
Yeah, smartphone selling companies.
Mobile, you have smartphones, you have tablets.
Yeah, electronics item, computing electronics item, you can say.
Okay.
Like they are also providing laptop as well, mobile phones, different kinds of steps.
Okay. Okay. Now the questions comes when we have a need and a one particular company, if it serves that particular purpose, why we need so many companies? Why we have so many companies doing the same thing? I mean, like the question is like how product design companies compete in the market. So this is
I
more
can
like
say,
okay.
sorry for the interruption.
Yeah, please. Please.
So, uh, I believe like because they are just competing because they are approaching different kinds of user. We can say like because someone like the minimalist design, someone like the budget kind of electronics. So they are different niches of the users they have. So that's why they are competing, and they have lot of companies we have in the market.
Okay. Okay. So you are right. So it's more like how this particular companies actually evolve. If you see that their evolution from 2011. So first Samsung starts their phones little late than the iPhones. So iPhone when iPhone was first released, Samsung actually did not have a concept. But when actually iPhone uh, 3 came, then only Samsung starts selling their product. 2013, you can say. And the first product was, for example, I think Samsung S series was there, Samsung S, then S2, then S3. And with the evolution of the touch sensitive display, they are actually developing new products. Now if we see how they are managing their development in the back end. Now Samsung is a semiconductor device company. Okay, it's a semiconductor device company at its core from the very beginning. Okay, however,
Okay.
Apple is a design based company. That means Apple does not produce its own chips. Okay, but Samsung can produce. However, Apple have a better conceptual design in terms of uses. So it was like a synthetic design approach. But Apple is the first company who come up with a smartphone design. Samsung do not have idea, though they have the chips. So in terms of resource, they are much more resourceful, and in terms of resource, they have just the concept. Okay, so they are good at conceptual design initially, and they do not have much, their own manufacturing units. So what happened when Apple first come up with their concept? They try to manufacture it using external vendors. So even Samsung was a vendor to them initially in 2011. Okay,
Yeah.
so they used to have Samsung chips inside this first iPhone, and also they have vendors from China. So these are various vendors, and that's how they try to manufacture their phones. Now because of that, what happens, since they are using external vendors, and it was not developed in US, it was developed in China, somewhere in Korea. That's the reason the manufacturing cost went a bit high till date. Okay, so the manufacturing cost of Apple phones and devices are high because till date they do not have their own manufacturing setup. They prefer to do the business like that, like vendor based business. So they will take chips, they will take companies components from different companies, and they will assemble probably in house. Samsung, on the other hand, have the edge over resources. It can produce its own chips, it can produce its own battery. So it was a technology based company, and later they hired a team specific for designing smartphones, and then they come up with smartphones. Now, manufacturing cost for them is not that much compared to this. That's why Samsung phones can be available at that time something around 7,000, to 25,000. I'm talking about in 2013. So that was the price range in which Samsung phones were available. However, Apple phones at that time also, it was more than 35,000, 50,000, that range. Even Apple iPhones. Yes. Because of this particular business strategy, because they need billions if they want to invest in manufacturing. Now, what Apple thought was that will not go for the lower paying customer segment, will go for the higher paying, the people who are capable of. So they concentrated the customer segment which have much higher affordability. Okay. However, if you see Samsung, it tries to cover all the segments. Okay, so you can have lower middle class people, they can also afford, sorry, here lower middle class people and also high class people. So people from all different segments in a society can afford these things. Okay,
Yeah.
so this is how company do business when they try to sell products, they when they invent products. Okay, someone tries to play with resources, they the entire game of business with resource, so they try to capture the bigger market. So profitability wise, Samsung have greater profit, but in terms of design and sophistication, Apple is a bit more sophisticated than Samsung, because in order to stay competitive with companies like Samsung, they needs to have their edge over design. They cannot compromise on design, because otherwise Samsung will have a better edge in terms of price. That's why they try to hire the best designers, industrial designers or the product designers in the world, and then they try to make their phones more usable. They have very specific teams for UX, different teams for the physical product. Okay. And they have also consultation with institutes, academics, so that they can arrive at a more usable product, which have a greater design edge. Okay, so Apple is playing the game of design edge, like design superiority over Samsung, and that's how they are doing. Now, both these companies have versions of their phones every year, and this is now like till today also, Samsungs are still, they are making their phones, and Apple is still making their phones. Okay,
Yeah.
so how do you think they still compete with each other?
For the Tesla or Hyundai, I guess we are
No,
talking
I'm
about.
talking about Samsung and Apple. Still, they are producing, right? It's not the initial era where smart touch sensitive displays are first invented, but now
Yeah.
like both have phones in higher range,
Yeah.
and now how they are competing.
We can say like a different electronics they are introducing. Like we can say laptops, like Apple providing the MacBooks over there, but the Samsung have a different like something like
Okay,
for
so
the
I'm
making
just
the Google
talking
Chrome.
about the same product. So let's focus on only the phone.
Okay.
So
Talking about the smartphones, basically introducing new features is the plus one, I guess, because the Samsung camera and there's always a good debate over there, like the Samsung camera about and the iPhone 13 camera, something is going
okay,
on,
so
and the
see,
processor.
now what they are doing, when they have reached some sort of maturity in terms of technology, they are trying to play with their features. Okay.
Yeah,
Now you see Apple and Samsung both are trying to play with features, like they have four cameras. Okay, Samsung also come up with four cameras. Initially people used to have one camera. Now Samsung come
yeah,
up with a curved display. They have now a curved phone. Apple still doesn't have a curved phone, I think. So this can be folded, right?
yeah,
So now this is a era where unique value proposition is required to stay competitive in the market. And for that, companies are actually going for innovative features that can actually lure customers to their products. Okay. Even
Yeah.
companies like Tesla also coming into picture, and they are also trying to bring new smartphones because everyone have seen that market of smartphones. And what Tesla is trying to do is like they are bringing the Skynet technologies. Have you heard about that?
Not yet, sir.
Okay, so Skynet, they are launching their private satellites
Okay.
so around the earth. So this is like the earth, so they have their set of private satellites, and they are trying
Okay.
to create some sort of network mesh over the earth. So these are some low flying, low orbital satellites which are creating the network. So you do not need mobile towers over earth because how the Samsung and Apple phones, they have a GSM module, right?
Yes.
Because to so there is one satellite which is actually transmitting these 4G 5G frequencies, and we have the towers which actually transmit these frequencies. Now Tesla come up with a new idea that we'll have a network of satellites orbiting over the lower earth orbit, and we do not need these towers, we do not need the towers in the on the earth space. So every phone now can subscribe to this satellite network, and you can have a satellite linked phone. And that's how actually the Ukrainian army is now using their communication in the Ukraine Russia war. Okay, so this is a new thing that Tesla had do. So basically, what I'm trying to give you, try to tell you that like every company is actually trying to identify innovative way how they can capture a particular market. Even Hyundai also have a smartphone. Back in 2011, it has a resistive touch phone. But because they do not have a in-house chip semiconductor industry, that particular phone could not be globalized, and it was mostly used by Korean people. And still, I think they have that particular phone series in South Korea, but it is not a globally available phone. So Hyundai was not a global player in terms of smartphones. So everyone is actually trying to develop their own ways of staying competitive in the market. Okay, so who are the people? That's a question. Like, who are the people who actually take care of understanding the requirement, like what needs to be changed, what needs to be done for future? I mean,
Yeah, I believe the first people is the sales guy mostly, because they actually comes to the requirement, then they just shift it to the product design team. We can say that
okay,
the marketing and the sales guy goes the requirement, like this is going wrong and this is the issues happen for the product, and they just go to the product design team. They analyze the requirements and what are the issues going on. Then they just make improvement, I guess.
okay, correct. So basically, the product developers or product design or development team is constantly working, and the marketing and sales people are constantly working in order to in order to stay competitive in the market, in order to come up with new products. Okay, so it's a job of a
Yeah,
product developer and designer to keep the business ongoing. Okay,
yeah,
so when we see this sort of evolution of a product from various format, like initially it was like a competition between touch sensitive screen to something now where we are much more playing with only features, not about technology. Because technology wise, inside I think most of the phones are same, like they are using same quad core, octa core memories, processors. Okay, they have 4 5 cameras. So in terms of now, people are playing with features. So how can we, identify, like how can you categorize these different types of design? So what are the various types of design come into picture? So you need to understand this particular concept.
Yeah.
So do you know what are the various types of product design based on this particular discussion we had?
Uh, Product design is something like we can say, like there are two methods basically. Something like the one is like we have to find the requirement and to start working on that part, and other one is like we just find a requirement, break down into small parts, and we just put it, take it up as improvements for the product.
Okay, so no, I'm asking about like how can we differentiate various types of product design. So I'm not telling you like how to conduct a activity, but more like how can we categorize the various types of product design. I think have you gone through the week 2 video lectures?
Not yet completely.
Okay, because the assignment date is very near 9th of August. Okay.
Yeah, today I go complete on this.
Okay. So try to be attentive here in this class. I will cover most of the concepts. Probably with these objective sessions, also you will be able to answer most of your assignment questions.
Yeah.
Okay. So there are basically three types of design. One is called original design. So there are some assignment questions probably which are giving example, like they ask like is it original design or is it the other kind of design. So there's something called original design. Then we have the adaptive design and we have the variant design. Variant design. Okay.
Okay.
Now, original design, how we define original design? So, original design is the design when we synthesize new knowledge, new knowledge to some sort of product. So, this is synthesizing knowledge, synthesizing knowledge to some sort of product, some sort of design. This is what we call it original design. Example can be a processor. For example, if you see why it's a new knowledge, because prior to this particular product, what we had was transistors. So this is transistors. Before that, we used to have vacuum tubes. So vacuum tubes were earlier developed and used to operate radios. So inside the old Murphy radios, you used to have the vacuum tubes. Okay. Then the era of transistors comes. So vacuum tubes to transistors, it's a original design, because in order to make this particular product, the transistor, you need to have synthesis of a new knowledge, because there is no link between vacuum tubes to transistor, which is a PN junction. Okay, so transistor, then transistor reduce used to come. Now next, back in 2000, 1990, that time, or probably before that, 1980, 1970, people started coming out, how can we increase the computational power, how can we actually store some memory inside the transistors. So people have thought about cache memory, how we can actually have RAMs, ROMs. So all this thought process goes into new knowledge creations, and that's how we have a processor developed. Okay. So
Yeah.
this is what we call as original design. Okay. Now adaptive design is next. Now adaptive design is something which uses original design as a component, or it's a adaptation of something already existing. Okay. Example can be a PC. Okay. So when processor was developed, there are a lot of products that evolved. Okay, you have a PC, you have a washing machine. So you have washing machine, then you have a television, TV. Okay, so there are a lot of products that can come, that actually the new scope was found when actually this processor was developed. this particular product was developed, then actually the product design people, they have realized that there can be different concepts which can serve different purpose in a society. So washing machine can be some sort of device which can actually wash cloth automatically, or there can be some way how we can actually watch movies. There can be also computers which can use for computation. So see, all these products, all these or design of all these products are possible only because of this particular invention. That's why these are called adaptation of the original invention. Okay, so this is the adaptive design. Clear?
Yeah.
Then we have, for example, this particular PC. Now people thought, okay, we have a PC, but PC market is already flooded. We need to think about some more usable way of computation. So people have thought about, okay, come up with laptops. Let's make this here and the keyboard, bring the keyboard here and the CPU behind. So it's a new product design, but knowledge wise, there's nothing new. It's an adaptation. It's not an adaptation, it's a variant of a CPU. It's a variant. It's a variant of a PC. So this kind of design is called variant design. Now variant design also can have incremental designs. So there can be like the laptops from different companies with different specifications. Apple laptop, Samsung laptop, like that. Now, as a product developer or engineer, the goal, this is the toughest. The goal here is to synthesize new knowledge into feasible product. That's the reason synthesis of a vaccine for coronavirus was a original product, and it is the most difficult part. It's a most difficult way of designing a product, difficult type of design. Okay,
Okay.
because there is no new old information prior to that. Okay, that is called original design. Now, in order to develop adaptive design, you need to be creative how existing technologies can be used in a smart way so that you can come up with different concepts. So this is the skill someone needs, okay, as a product designer. When you have already existing technologies, you can how you can combine. For example, the previous product that I gave example, like the saver, the electric saver is a adaptive design because it use a original technology. For example, a processor, a motor, okay, and then you have cutter probably. Okay, so these are original products, and this particular product, the saver, electric saver, is a adaptive design. Clear?
Yeah. Yeah.
Okay. And when we try to make a version of adaptive design more usable by making variation of it, it's called variant design or incremental design. Okay, and this is the most easy part. Okay, so this is the
Yeah.
most easy task and easy to copy also. Okay, so easily someone can copy your designs if you only go for variant design. This is also someone can copy still, but you can have patterns, design patterns in variant adaptive design. So you can protect yourself from stealing. But synthesis of original knowledge, these are mostly trade secrets, and companies can choose not to disclose how a particular product is made. Okay, still people do not know, for example, how what is the original formula for Coca-Cola. Okay, so these are the
Yeah.
synthesis of knowledge. So this is the most difficult part, this is the medium one, this is the easiest part. So a designer, based on the requirement, needs to actually come up with these many different types of design when they actually work in industry. Clear?
Yeah, clear.
Okay. Okay. See, this is an example how a product can evolve. Okay.
Yeah,
See, this is a evolution from a original product to a adaptive design to a variant design. The other way is that the original design also evolve. Okay. And
yeah,
this particular evolution of a product helps in the variant design. Okay, so this helps. A product can evolve this way also, a product can evolve this way also. This is more like a technological incremental design change. This will help in actually creating new variant of a design. That's the reason why you used to have phones with different specifications. So iPhone 1 probably use some sort of CPU, GPU, graphical processor. Then they have MediaTek processors. Now they use NVIDIA chips. Okay, so this is the kind of design evolution that happens at a company level. For example, if it is a company who is producing only chips, this is the kind of development it happens. But usually, when you are a design house or a product design company, this is the way how actually product design happens. Okay.
yeah. So I just want to know one more thing while talking about the Intel chip. So this is Intel Pentium dual core. So this is a variant design, right, of the core one.
So it depends. So if it's a new knowledge, if I don't know exactly, but if to develop a Intel Pentium dual core, if the knowledge required is actually a new knowledge, then it's a original design.
Okay.
Although it looks similar, maybe the internal, it's not just the architecture change, maybe at the core level, at the material level, there are some inventions happen. See, I'll also introduce another concepts here which was not discussed in the lecture actually. What happens when we break down a particular product? There are components. Let's say this Intel core, when we see what are the components inside this particular core, there are probably transistors, probably some sort of superconductors, superconducting parts pathway. There are some way how these PCBs are sandwiched, because probably we need multiple wirings. So very complex wiring. That means single PCB, double PC, four PCB will not help. Probably you need a new way of uh, bypassing signals or communicating from different layers. So we may heard about these dual side PCBs, double side, triple side, right? So connection from top of the transistors actually can go below, and then actually it can reach somewhere here. Okay, and there can be another components which I don't know actually. But what I want to say here is that there may be original product development at a component level. For example, this processor, Intel processor, is a component to this particular design, because there are a lot of other products also required. So a PC needs a processor as a component. There are RAM, there are monitor, there are mouse, all these are products. So every component is also a product. So components are also product, unless you have a hierarchy. So when there's a hierarchically higher product have a different use, the underlying child product we call is a component. What may happen is that when Intel dual core was developed, we need to see at a component level, maybe the products we are, the components are also products actually. Okay, because Intel processor is also a component to a PC, right? For a PC,
Right.
Intel processor is a component. But for a Intel processor, the transistors are component. But transistor itself is a product. Now there can be original design in the transistor. So transistors are newly developed so that it can be made more small. Okay, small form factor. So
Yes.
for that we need to harness new knowledge synthesis. So this can happen actually. So that
Okay.
time, if you see then your Intel processor is actually adaptive design, because now you are using original product to create a different version of a product. If you say previous generation Intel processors have a different transistors, okay, this is transistor one, and the dual core have a new transistor technology. Then what happens from this particular hierarchy? The Intel processor and these dual cores are actually two different adaptive product. Am I clear?
Yes, sir.
it's how
Uh,
you it's how you see the product actually. There's nothing absolute. Okay,
yeah, I got it.
unless a product is just have a one standalone utility, it cannot have any other use. Like a, probably for example, a screwdriver, for not screwdriver, a screw is also a product, but it needs it goes when it goes inside a table, probably it's a component, right?
Right.
Probably now this table may require a new kind of screws which are anti-theft screws. So, and the screw is now a original design. The table is a adaptive design. Got it?
Got it. Yeah.
Yeah. Okay, so there's another term which is most often heard in the industry: redesign. Right? So how redesign is different than these three types of design? So we have original design, adaptive design, and variant design. So what is redesign?
Yeah, I believe redesign is something making the component, making the product again for the different user, for the different needs.
Yes. So if you, it's not for different user. If you make a different user, then it's a not a redesign. It's called design,
Hmm.
because you are trying to capture a new different market or different user profile. That means it's a new design. It's not redesign. So redesign happens when there are feedbacks from the market or feedback from manufacturing or feedback from something. Okay. Now first feedback comes, then only you do design. So it's called redesign. For example, a feedback from the customer segment can be like, this product is not good, it has certain issues. Then you redesign a product. For example, redesigning of bullet chassis, the Royal Enfield bullet chassis. So Royal Enfield have a new version in 2000, I think back in 19 or 2020, I think. So where they have changed a new chassis. It's not for new customers. See, customer segment is same, technology also same. It's just because they have a complaint that is the handles are vibrating, the tank is vibrating. That's the reason why it's a redesign. So redesign is, can be any of these. Okay. For example, a original product, a original design was a new knowledge, but at the manufacturing level, the design failed because it cannot be manufactured. Then you need to do the redesign. So original product also can be redesigned product. So redesign is a requirement when there's a feedback from customers or feedback from manufacturing or any from anywhere. Okay, so first feedback, then you do the design. It's called redesign. It can be also adaptive design. It can be adaptive redesign. Similarly, for example, adaptive redesign can be a redesign can be curved curved display. Okay.
Yeah.
Okay, because the feedback was that the end pixels are not visible. So probably that's a feedback taken from customers, and you redesign it PC and it's a curved display. Then it can be also very easily, it can be a variant design. For example, you made a uh, laptop, but particular button is very small. Okay, so feature, basically feature is not up to date. That particular button is small, or uh, you have floppy drive which is should be on the right side, because it is left side, it is actually affecting something like that. Okay, so you are now changing to this side because of after getting a feedback from customers. So this is redesign. So redesign is not a different type of design. The types of design are only these three, because there can be tricky questions in this particular course assignments and exam. So redesign, just remember, redesign it's not a different type of design. It's the design, it's a reiterated design because of feedbacks from customer, market, or somewhere. Okay.
Yeah.
Okay. Now, have you heard about design approaches? So design processes.
Yeah, I heard about this.
Okay. So what is your background?
Product design,
So you're a
right?
product designer, right? So what sort of product design methods you follow?
Digital product design, something like relevant mobile applications design.
So you are a UX designer or product designer?
UI UX, you can say. In some domains, I know known as a product designers. Basically, it depends on the company, I guess. The product designer and the UI UX designer
Oh,
need
okay.
to be
Okay.
covered.
Fine. So, why we use design processes? Okay.
Yeah.
So, design processes helps us do things in a more systematic way, so that the failure can be limited. Okay. So, one is why we need design. So, if I ask why we need design process, one is if you follow some sort of known, predefined path, probably which was successful in the past. So designers probably in the past have not followed any path, any process. They have different designers follow different approaches, but there are some of the perspective or some of the paths which were well proved. Like those are like very good approaches. So those are now taught to students or the design community that okay, these are the approaches. So this is what is a design process called. So this way of designing probably will minimize the failure in the industry. So that's why we need design processes. And also, not everyone is creative. Not everyone are born designers. So probably if you train anyone with a design process, probably average people also can do some design. Okay, but by birth someone can develop nice concept, better product, but at least most of the people, if they follow systematic approach in the design process, or probably they can do something. So these are the two reasons. One, because this is a fail proof approach. Two, because even the, unskilled or like beginners also can learn, because due to that we use design approaches. Okay, so certain products, depending upon products, there are different kind of approaches required. Okay, and there are two very important processes popular, which are stage gate and spiral processes. Okay, now these are the generic names. Now stage gate, spiral, these are the generic names what you may heard in the industry or in academics, probably a specific version of that, probably user-centric design process or design thinking process. Okay, so these are something like a stage gate process. Okay, so these are the versions of that were taught to students, but in general we define the product development, whether it's a software product or it's a consumer electronic product or any product. Like we have generally have two different version of design product design processes. One is called stage gate. So what is a stage gate process? So in stage gate process, what we have are stages, then there's a gate, then stages, specifically stage, and then gate, stage, and gate. So like that, it can be many stages and many gates. Example can be, so in each stage you perform different activity. Okay, so you can also say these are stages or phases. So have you heard about design thinking process?
Yes, sir, I heard about it.
Okay, so design thinking process uses these stages to define the first stage for need identification, second stage for to come up with some concept ideation, third stage to come up with some sort of prototyping, fourth stage to verify those. So like that, they define their own way what should be the first stage, what should be the second stage. And gates are how we check. Once we do this, we open this gate and then we enter this second phase. Okay, so these are basically the checkpoints. The checkpoints, what we check, for example, if first phase is need identification, then we check whether it's a valid need. Second phase, if it's it's a ideation, we check whether it's a valid idea, whether the idea is feasible or not. Third stage, if it is manufacturing, we see whether this particular product is manufacturable or do we have the resources. So we can have many checkpoints. Okay, at the check gate, we can have multiple filters which we can use at the gate to move to the second phase. So this particular approach of phase and gate or stage or gate, it's called a stage gate design approach. Now design, they're not all design processes are like this. So design thinking process break down the stages into need, like ideation, etc. But also it can be something, for example, for automotive design or something, these can be individual parts. So stage one can be design of the engine. Stage two can be design of the lights. Stage three can be design of the wheels. Just giving example. Okay, so it's not required,
Yeah.
like we can actually break down phases and stage and gates into as a components also. Okay, so different industry follow this in different way. Okay, so this is stage gate. So which of these products do you think actually follow this particular approach? And what do you think are the benefits and limitations?
I believe the design of the vehicle uses the stage gate basically.
Okay, so I already gave that example. And any other?
And then we can say the second one is SolidWorks. Is the company name?
It's a software used for CAD modeling. So
Okay.
it's a for example, for computer modeling, it's a tool which can actually model like the virtual model of a mouse. For example, if you have a mouse, you can actually first create this particular computer model first in the computer. Okay, then you visualize and then actually you can manufacture. So basically, it's a software. Tell me.
Okay, okay, cool, cool. So I believe this also uses the stage gate model.
Okay, and okay, actually, let me tell you. So this is wrong. Actually, we do not use stage gate here. Let me first clarify you. So products like this, which are like the physical products, not the softwares. These sort of products, what happens? Uh, we need to make sure that every component or every parts actually perform well before actually product can be launched in the market. For example, we cannot sell a product if the wheels are not working. We cannot sell a aeroplane if the rudder is not working. So what happens when we design a physical product? We make sure, for example, if we have a design process in the pipeline, so what is the requirement for a aircraft? So this is a Tejas aircraft, Indian Tejas aircraft. So probably the list of need is a aircraft, or it can be like a Indian what is called LCL, light combat aircraft. So we need is a light combat aircraft for India. The requirements can be it should have very good radar so that it can detect enemies 100 kilometer. It should capable of launching missiles which are beyond visual range missiles of, for example, 150 kilometers. So these are like some of the requirements that I am just trying to tell you. For example, also it, for example, there should be two people sitting so that one can look for only combat and one can only look for the flying. Okay, so two people. Okay, then also it should engine should fly at a supersonic at particular Mach speed. Okay, so see, these are the requirements. So usual, as usual, we have a need, we have a requirements. Now when we actually uh, go for the design or development activity, each of these needs to be done separately. There is no connection between these four different products, because this is which kind of product? This is a adaptive product.
Yeah.
Okay, so
Yeah.
this is an adaptive product. Okay, this is an adaptive product, and in such kind of product, what happens? You have multiple original products. Okay, now here we need to first make sure when we are actually making a aircraft, we have the radar done. Radar team is working on radar, and once they finished, then only we can think about what should be the size of this particular cone, because this is the area where radar fits. Then we can actually think about, okay, let's plan the internal electronics and how this particular controls will be provided in this particular aircraft. Okay, then probably controls will be done, then probably the missiles, okay, how they will fire, then probably the engine. So probably the engine is the first thing because it will power all these units. So engine will be the first thing it will develop. Once engine finish, we'll go for this. Okay,
Yeah.
so benefit of a stage gate approach is that you make sure at every stage that you accomplish a set of goals, a pre-decided objectives. Okay, so in stage gate, all these gates are to check if specific objectives have been reached or not. So for a product like this, we need to make sure that actually we have achieved the individual objectives. That's the reason why we have stages. Okay, and we cannot finish the product till we gone through all the stages. That's the reason why in stage gate, that's a limitation also, we need to wait till the you know last component in your product also finish developing, then only you can assemble the product. That's the reason why we spend almost 10 years in the pipeline and still we are developing this particular aircraft, because stage gate approach have this particular limitation, and we cannot launch a product without actually having a specific component. Okay, that's a benefit is we make sure every stage got achieved, but limitation is that it's a long process of delay, and once a particular stage is complete, you cannot actually go back. There's no way you would change the radar entirely. So all the assumptions, all the calculations needs to be done upfront at the very beginning. So what should be the size of the radar, what should be the specification, everything needs to be done at the very beginning. We cannot change things in the middle, because otherwise the another particular component will get affected if there are specification change in the previous thing. For example, if engine got changed, probably the weight of the entire aircraft will change. Okay, then probably you cannot carry that many missiles. Okay, so there are dependencies, so you need to decide everything upfront, and there is no way you can go back once a particular stage got completed. That is the limitation. Okay, so in this particular example, the car and the aircraft actually follow the stage gate approach. Okay,
Yeah.
the another approach is the spiral design approach. So spiral design, let me tell you an example. For example, if you see product like Windows, what happened? You have Windows, I think 98, then 95 was there before Windows 95, right? 98, then Windows 2000 was there also, 2000 XP was there, then Windows 7, then we have Windows 8, Windows 10, 11 till now. Okay. Now, in software development, we do not try to achieve all the functionalities at one go. We try to slowly improvise the product through a long run, and what happens, we have a individual stage gate for every commercialization, for every stage in the commercialization pipeline. Okay, so here the timeline is targeted prior to product development, not like development of cars or aircraft. Here timeline is fixed first. So T1, T2, T3, T4. But in case of aircraft or in case of car, the timeline is very difficult to fix upfront, because if when you are working on new technology, probably some delay may occur. But in case of software, what happens, like, you do a good estimation, and also if something does not uh, finished in a timeline, you release a beta version of the product. At least you release the beta version. So that's the benefit of virtual product. And here we have multiple stage gate for development. So for each version, we have one particular stage gate. Okay, this is stage gate stage. This is this is gate. This is again stage two. This is gate. Stage gate. Now all these stages are pre-decided and are decided in such a way that we can actually meet a particular specification upfront. So here time is a constraint. So we need to deliver something within time, and we release a commercial version of it. Like that, actually softwares are got developed. Okay. Now after that, another cycle of stage gate happens, and we have Windows 2000. Then again we have Windows XP, then another stage of stage gate, Windows 7. So like that, this particular approach of designing is called spiral design, because here when we have specific timeline and we have lot of development activities, you cannot make these as straight lines. The the amount of activities, when you draw activities versus time, this form the structure of a spiral. It forms a spiral structure. That's why this particular approach is called spiral design approach. Now, can you tell me what are the benefits and limitations?
The one benefit I just saw, don't have to wait for a long run to completely achieve the overall objective.
Okay.
And the limitation, I believe, sometimes there are flaws in the product itself, right? So we still have to use the product with the flaws.
Okay.
That might be the bad UX or something.
Yes. Yes, so you are correct. So those are the benefits and limitations. So these kind of questions can be asked in your assignments. So just make sure like you understand these things. So here SolidWorks, which is a CAD software, it's released every year. 2011, 2007, 9, 10, so like a lot of versions. And you have the same basic versions and you have added features. Okay, and every year in the same at the same time, like, the company launched their product with new advertisement with new features, but launching date is same. So this is now mainly adopted in software solutions, spiral design approach. Okay.
Yeah.
Okay. Now, see, here are two products. Okay. Now, can you tell me like which particular product needs more skill or knowledge?
Okay, are you asking which product uses which more skills and knowledge, right?
Like for example, this is a 3D printer. Okay, there are two
Yeah.
design. Okay,
Yeah.
and one is a chair and one is a 3D printer. So which among these you think is technically more challenging and need um, in terms of time in more development time?
If you're talking about development time, so I guess chair will take more development time. But when you're talking about the skills, so there are different kind of skill, right? The using a computer and making a 3D or so 3D model basically, it's a different skill.
Okay,
And making a yeah,
let's say I am just here, the person who is making is a product designer. Okay. So a designer have a good design skill as well as good technical background. Now
yeah,
think like for the same person, which one will be easy?
it will be easy. I guess making a 3D modeling is easy for me. If you
Not
talk
3D
about
modeling, it's machine.
no, no, you're talking about the machine or the 3D model,
Not
the
not
output that it gives.
not model.
Okay,
I'm
okay,
telling you about the 3D machine, the 3D printer machine. I'm telling
okay.
you, and here is the
Okay.
chair.
Okay, I guess share is easy for me. I'm just thinking like if you're talking about the output for this one.
Okay,
Yeah.
not the output actually. So here the product is not the model. The product is the 3D printer. Okay.
Okay, okay.
So why I'm asking this, because these are related to the two stages, the two design processes that we learn. Okay.
Yeah.
This one, I mean, both are products actually. Both are physical products. Okay.
Yeah.
Both are physical products. Sometimes what happen, some physical products also they behave like a virtual product. So this is an example. So chair, the knowledge or the amount of information you require, how it design, what is the structure of a chair, it's not something new. Okay, what you may not have is the skill. So you can hire someone like a carpenter, and you can actually ask the person to make a chair for you. But what you probably know, like how to make a chair, like what a chair comprised of, right?
Correct.
So the knowledge required to make a chair is not new, and it is less skill dependent in terms of knowledge. Okay, you don't need technical knowledge.
Correct.
For skill, yes, the person who will be actually physically making it, you need to hire that person. But in terms of conceptualization, you do not need to have that technical knowledge.
Yeah.
For a 3D printer, however, even if you have the engineer, I'm just talking about when you are trying to make a new 3D printer. And an engineer is a general engineer. He's not a 3D printer specialist. He is a mechanical engineer, for example. Okay. Now you are the
Okay.
product developer and you come up with a new concept. Okay. And the concepts come up with your idea, which is new in nature. And this is a unique way how actually you will be printing. This is an example. Okay.
Yeah.
Now, in order to accomplish this particular design, the technical knowledge is something you require from him, but in terms of conceptual knowledge, this is something new in nature. Let's say. So, what happened here? The amount of synthesis, the conceptual synthesis is less. Here, conceptual synthesis required much more effort in terms of time and cognitive abilities. Okay. In such kind of product, when you develop, you cannot come with up with the product at a single time. So you need to do multiple iterations, probably hit and trial, and probably you need to improve software, or you can have to improve the features, and you try to see which particular configuration gives the best 3D printing results. So there are multiple iterations that you need to do. Do you agree? Hello?
Yeah, so
Okay.
yeah, I totally agree with that.
Okay. So what happens? So in such kind of product also, we cannot wait for a very long time till product is actually complete in by all means. In such products also, we prefix sometimes our timelines, and we prefix a version of it, and we launched a physical product. For example, if you see companies like Prusa, who are the 3D printer manufacturers, they have different versions of 3D printers. They have Prusa version, I think, 1, then they have Prusa i3, now they have Prusa MK i4. So these are different versions of 3D printers with added features and added software development. Okay. So sometimes physical products also follow similar approach when you try to reach the market at a specific time. Okay, so stage gate approach is not always for physical product. Sometimes spiral designs are also used, spiral and design approach are also used for physical products. It depends like what is the level of efficacy you require from the product. If it's a medical product, you cannot sell versions, you cannot commercialize versions of it unless you reach a specific level of safety or efficacy. Similarly, for aircraft, you cannot do like pusa kind of thing. Okay, so depending upon products, actually you can choose whether you follow the stage gate approach or the spiral design approach. Clear?
Yeah, yeah.
Okay. Okay, so this is the last concepts like from week 2. So here actually you need to understand what are the different stages of product development. So do you have any idea like what are the different stages? Have you gone through the lectures? So what?
Not yet.
Okay, so what
The
are?
main, I guess, yeah,
I think you know initially like we first understand,
yeah, I understand the research about the
yes, the
problem.
opportunity, the need. Okay, and for that
Yeah,
we do some sort of activity. Like probably in industry also you have practiced. For example, you go for field study, you do contextual inquiry, right?
yeah, yeah,
Then we do identify the problems, filter the problems, probably choose something which is more feasible, and probably you do also competitive analysis. You also look for feasibility, okay, market feasibility. So this is the initial phase, which is like understanding the opportunity. So this phase is called opportunity identification phase. Okay.
yeah,
The second stage is developing a solution, develop a concept. So this is the phase which is concept development phase. I think if you are a product designer, probably it's something very basic for you.
yeah,
Okay, so in the concept development phase, what we do ideation, we do functional decomposition of the concept, and then we do concept engineering also. Sorry about my handwriting. And then you come up with some concept. Okay. Third phase is the implementation phase. Implementation of concept. So names can be a little bit different, but the overall idea is that in the first phase you understand the opportunity, second phase develop a concept, then you implement the concepts. This is more like a actual prototyping physically and going for manufacturing, doing design for manufacturing, looking for components, raw material, the manufacturing practice, etc. etc. So these are the mainly three important stages of product development. Okay. So here's an
So,
example.
so I guess there is a one more stage sometimes we usually often use something like the evaluation of the design.
Okay, so concept evaluation is done here. Concept
Okay, okay.
evaluation is done at the development of concepts. So when you have more than one concepts, so you use certain matrices, filters, and then you try to see which of the concepts will be better. So this is where you do. So this is in the second stage. Okay.
Okay.
So
So do you think like the concept evaluation and the product evaluation are the two different things basically?
yes, two different. So product evaluation, when I say it is like the, I will say it is user testing.
Yeah, something user testing and the field testing we can say like
Right.
the
So
builder
user
testing and
testing,
this thing.
field testing is that implementation of a concept.
Okay, okay.
This is concept evaluation where you have predictions of particular concepts based on certain matrices via experts,
Yeah.
and they evaluate which concept is more feasible, more efficient. So there can be different filters, but this is the process which is done at the conceptual level, because you may have multiple concepts, and based on your expert analysis probably you can choose a particular concepts to work on. But here at the implementation phase, when you actually choose one product and you develop something, you also needs to verify whether these are like the some of the things you assumed, right, at the conceptual level, whether the actual
Right.
product worked or not. You need to do a user testing, and there if you find like okay something is not working, then actually at the concept level you need to go and change. So this particular process is not a linear process, it's a more iterative in nature, like that. If you think concepts failed, evaluation failed, none of the concept got selected, you need to do your understanding again or develop the idea, new ideas again. If you think the implementation level there is some failure, you need to change your concepts. So it may not be the user testing, probably at the manufacturing level. If you find like the particular concepts cannot be manufactured, the facility is not there, or you need to change parts of it in order to make it manufacturable, then you need to still do the concept iterations. You need to still develop a new concept. So this is a iterative process, but stage wise there are, these are three main stages. Okay, even
Yeah.
commercialization also falls within the implementation of this concepts. Okay. So when I say implementation, does not mean like the bench top implementation. It needs to be a commercial implementation. That means your marketing, sales, R&D, manufacturing all fall under implementation of the concepts. Depends like what is the scope of your venture, what is the scope of your company. If your company is just a service company who make concepts and sell to clients, probably your implementation of a concept means just user testing. But if your company is a OEM, original equipment manufacturer, for example, someone like like a bike company, Royal Enfield, probably you need to also go for user testing, then marketing, then sales. Then only your concepts will be actually implemented. Okay? So these are basically three stages in general. Clear?
Yeah, clear.
So this is an example. This is one of the previous my project, and this is where actually there's a need of a new remote control which can replace the button based remote controls. Okay. So first, in the understanding the opportunity phase, you have to choose a vision, like what you need to accomplish. Okay, what are the issues you've identified. So you have a vision, then you do some sort of need analysis. So requirement is that there are a lot of buttons in traditional TV remotes, so there should be some easy way how you can actually uh, you know, s- like that, navigate between channels. Okay. And you do competitive analysis. What are the different competitive products available also. Then next is the concept development stage, where we developed a small portable remote which have a very limited number of buttons, and it has a voice based interactions. So in that particular stage, what we have a conceptualization phase, where we actually come up with multiple concepts. This is the final concepts I'm showing. You also go for functional modeling, where you try to see what will be the how the components inside will be distributed. So you do functional decompositions. I'll be talking about functional decomposition probably in next couple of classes. And you also look for product architecture. So this is the architecture. So it uses some sort of natural language processing pipeline with a microphone at the front and a speaker at the end, and it actually sends signal to the setup box, and then the TV receive the signal and it operates. So you can actually name a channel name and speak a channel name, and then you can switch the channels. So this is the engineering concept engineering phase. So these are the different activities you perform in a concept development phase. So of course there are evaluation, all these things there, but I have not shown here. So these are some of uh, the activities you perform in concept development phase. Similarly, in the implementation phase, you try to understand how what are the engineering constraints, how you can develop. So you can actually go for product embodiment engineering. You try to see what components, what things needs to be go inside, and then you go for development, and you also do testing, user testing. Okay, so this is the final product. So this is how product development happen, and it shows like the three broad stages: the understanding the opportunity stage, development of a concept stage, and the implementation stage. So that's it actually for week two. So till week two, you have this much content for the course, and the deadline is for the assignments is 8 of this month. So please try to finish your assignments and submit them. So thank you. So if you have any questions, please feel free to ask.
No, sir, not right now. Thank you for your time.
Thank you. So next, please be present in next Saturday. So same time. So classes will be there. Thank you.
Yeah, sure. Yes.